Hi, I'm Kian, and I'm back with an interesting calculus question that actually combines all the important concepts taught in Calculus 1 and Calculus 2. So if you have this actually integral, I'm just integrate the sum from 1 to infinity of the derivative with respect to x of the limit as h goes to 0 of 1 over x plus h squared minus 1 over x squared over h dx. Okay, so what I'm going to do is that first of all, I'm going to evaluate the limit because this is the most inner part. So part 1, I'm going to label it as 1. Should take the limits, and I'm going to make the common denominator immediately, and I'm going to simplify it to not occupy much space because we have also longer parts to this question. So we should take the limit as h goes to 0, and then if you take the common denominator and divide it by h, the common denominator would be x squared times x plus h squared. And then we should also multiply by h because we're dividing at the end by h. Now what I'm going to do is that I'm going to actually make the common denominator. So we should multiply the top fraction, 1 over x plus h squared, by x squared, and then subtract x plus h squared. So we get actually x squared minus x plus h squared. And now we see that this is in the indeterminate form when we evaluate the limit at 0. So we can actually simplify the numerator, and if we simplify and factor out the h, because the x squared cancel, we just get h times negative 2x plus h, and then all over the denominator. Which is x squared, and then times x plus h squared times h. Okay, now we can see that the h's cancel out nicely, and when we take the limit as h goes to 0, we can just put 0 where we see h. So we just get negative 2x over x to the power of 4, which is the same as negative 2 over x to the third power. So this is the answer to the first part of the question, but we're not done because then we should take the derivative. So I'm going to write it part 2. We should take the derivative with respect to x of negative 2 over x to the third power. So using the power rule, we can write it that negative 2 times x to the negative 3. Differentiating it, we get 6, and then over x to the 4, which is the same as 6 times x to the negative 4. And now we should go to the third part. The third part, we should take the sum from 1 to infinity. So what would that be? So I'm going to write part 3. So if we take the sum from 1 to infinity, and then we have, if we change the variable, we get 6 over n to the 4th power. Well, if we take the constant out of the sum, 1 over n to the 4th power is a famous sum, and it can be derived from the famous 1 over n squared, which is proved by Euler to be pi squared over 6. But I have a video that shows how to evaluate the sum from 1 to infinity of n to the 4th power, 1 over n to the 4th power. But for now, we want just a value, and the value is pi to the 4th power over 90. So if we multiply pi to the 4th power over 90 by 6, we just get pi to the power of 4 and then over 15. Okay, this is our answer to part 3. And lastly, the main part of the question, which is to integrate this. So we should actually integrate pi to the 4th power over 15 and then with respect to x. So this is just a simple integral because we have a constant, and integrating a constant, we just put an x in front of it. Just put a variable in front of it. So we get pi to the power of 4 and then over 15 times x and then plus c. Thanks for watching. Please subscribe to my channel and